Hi everyone, Matt Turner here. Today we're going to talk about why sustainability and conformity don't mix. One major impediment to sustainable futures is that it's hard to get lots of people to adopt sustainable adaptive behaviors, even if they're proven and cheap and effective. One example is prescribed burns to prevent wildfires that Sierra Miwok in California have been using for millennia, for a long time, to prevent catastrophic wildfires that destroy the whole forest and their livelihoods and everything. And the way to do it is through prescribed burns. And these are ceremonial burns like the one shown here. There are modern examples of new innovations where we have the same problem. There are good practical behaviors, sustainable practices that could be adopted by lots of people if only they were convinced that they were good to do. One way that we learn from others is by looking at how well they're doing. You know, we check, hey, look, our neighbor is really happy with their solar. It's working out for them, cheaper bills. Maybe I would want to do that. And there are lots of examples where colonist populations, might have some adaptation, some sustainable practice, or something that benefits sustainability in general. And public health is one of those things. Oftentimes, indigenous populations don't get access to public health, or they don't know how to take advantage of public health resources. There are many indigenous practices that are sustainable that could help protect us against catastrophic wildfires and things like that, or in the case of the South Pacific Islands, protect people from sea level rise. Coastal mangrove forests, just like prescribed burns, used since ancient times by indigenous people in the South Pacific Islands to prevent against inundation when tsunamis hit or when there's a cyclone or things like that. And too often there are technologies from colonist populations like gray infrastructure, seawalls that end up being maladaptations. These seawalls, for example, often pool water inside. It holds water in instead of keeping water out. And the indigenous solution of coastal mangroves would have worked much better and been a lot cheaper. In this lecture, I want to talk about what is cultural evolution and how could cultural evolution help us identify strategies that will be best for promoting the spread of sustainable behaviors. Cultural evolution, according to Henrik and McElreath in this article, they say how many different models of interaction among different learning mechanisms indicate that natural selection will very often favor a mix of social and individual learning with a substantial reliance on conformity. Conformity here is the tendency of people to do what others do, or do the more popular behavior instead of what might be the more beneficial behavior in the little illustration of people choosing whether to adopt solar panels or not for rooftop solar. What I wanted to say next is that conformity and the success biased example that I gave with the solar power, with deciding whether or not to install solar panels on one's roof, these are different social learning heuristics. Often these have been called social learning strategies in the cultural evolution literature, but I think to be commensurate with other social science disciplines like cognitive science and psychology, I think heuristic is the right word to use here. And conformity differs from success-biased learning, as it's called, where people are more likely to learn from others who are successful. And there's also random, where, sometimes we just see people doing something, it looks kind of fun, we happen to have time, and then we want to go try that behavior. So that's random. And then there's also prestige bias, which is important, which occurs in the real world. And it's just the fact that we often like to learn from people who have influenced lots of others. If other people have learned from them in the past, chances are they're going to be a good teacher for us. Conformity differs from these other three that I listed here in that conformist transmission, or when people learn using the conformity heuristic, they are basically a slave to the majority opinion. I want to ask which one of these is better for sustainability, for promoting sustainable practices. And what I'm going to explain today is a very simple model of why success biased learning specifically, just one representative of a freedom-based learning heuristic, why success bias is guaranteed to do better than conformity in the case where the behavior or the sustainable practice is uncommon. It just can't make uncommon things, uncommon practices become common ones. So I'm going to show that. I'm going to show that model right now. To model different learning heuristics, we're going to use something called the prevalence dynamic. And this is a generalization of something you might have heard of, the replicator dynamic. In a future lecture, I'm going to explain how we get to the prevalence dynamic from the replicator dynamic. But for now, I think it's going to make sense if I just say that the change in the prevalence of an adaptive, sustainable behavior over time, we can write it as follows. So delta A is the change in prevalence over time. So we're thinking about the rate, like the velocity of change in prevalence over time. It's like the velocity of prevalence. So what we're looking for, what we want to know is for some value of the prevalence, if we know that 50% of people have adopted rooftop solar, for example, if we know that 50% of people have adopted rooftop solar, how much will that number change in the next day, in the next week, in the next month? And we use, so what we want is we want delta A, which is the change in prevalence, divided by delta T, which represents the change in time. We're going to say that this is just equal to the probability that somebody keeps or the probability that somebody starts doing the adaptive behavior on the next time step. Probability minus the prevalence of people doing the adaptive behavior right now. Simplify this a little bit and call this the probability that some individual whatever, pick one at random. This is the probability that I will be an A doer at time t plus delta t minus, and we'll keep this in here for now, the dependence on t. So now we have the change in prevalence over time is going to be equal to the difference between the probability that any individual I is going to be an A doer, someone who does the adaptive behavior A at time t plus delta t minus the current proportion of individuals, or the current proportion of individuals doing A, or in other words, just the prevalence of the adaptive behavior. Okay, and just to close this out, here's how we can write this very compactly, understanding, we're going to come up with a more compact notation to write these same components, and here's what we'll do. This is the prevalence dynamic, and it's kind of obvious, might seem obvious, but this move, writing behavior change as this prevalence dynamic, allows us to create a commensurate model of conformist transmission or conformity heuristic, using the conformity heuristic, and comparing that to success biased transmission. And so we'll do that next, after I clean off this board. Next, we need to specify different prevalence dynamics, different forms for each prevalence dynamic for each one of the two learning heuristics that we're going to be studying today. So I'm going to write the prevalence dynamic again, and then we'll define the two types of learning heuristics. Okay, and now, so what this is saying, just to say it again, that this is the change in the prevalence of adaptive behavior A. It's equal to the probability that an individual keeps doing behavior A or starts doing behavior A, minus the current proportion of individuals that are doing behavior A, or in other words, the prevalence of behavior A. And how we define different prevalence dynamics for different learning heuristics is by defining this P sub A, we'll call it. So I'm going to write this out, and I'm going to just make a note that this is what we changed to specify different prevalence dynamics. And so what do different learning heuristics look like in terms of this probability? Let's start with the success-biased one. And I'm not going to write the equations right now, but let's just think about what happens for different values of A. At the extremes, let's say. So what we're going to be doing is we will change, we'll see how A dot, this change in prevalence, which is just, A dot is just, it comes from, it's called Newtonian notation. It's what Isaac Newton used for calculus, and it represents the change in prevalence over time. So this A dot, we want to write A dot as a function of A. And we know that A goes from 0 to 1, just because it could be negative, and this A dot will be negative over this range of A. So we have 0 here, and then this would be, say, minus C and plus C. And these are just different numbers that sort of constrain, let's say, the range of this A dot. So what's going to happen when PA, let's say that PA, we'll have two different lines, okay? We'll use two different colors, one for the conformity learning heuristic and the other for the success-biased learning heuristic. Red was for conformist learning, and green was for success learning. So I got my red marker here. I'm going to draw a line. We're going to make a little legend. Okay, and this is going to be conformity. And we'll use green still for success. And okay, I got my green marker now. Let's start with success bias. So the change is not too great at first, but it increases as A increases. And let's mark, I want to have a spot for, it's important to think about what's going on at the halfway point, where this is half the population doing the adaptive behavior, where the difference between the success heuristic and the conformity heuristic is most important. So I wanted to draw a little bit more of a line, a little bit increasing. So we know this success bias learning is going to, the more people are around, the stronger the selection is going to be for the adaptive behavior. And let's think about what happens at 50%. So before 50%, we're going to be increasing, and we're saying C is just going to be this arbitrary, for our sort of sketch of the formal model, this C is going to be the extreme value of the change in prevalence over time. Okay, so here we have, there's no reason to think that this is not monotonic, that it stops increasing, that the change in prevalence stops increasing as a function of A. It's going to keep increasing because more and more people, there are still people who need to learn. There are a lot of people who haven't adopted the adaptive behavior yet. And there are lots of teachers, only up to a point though, because then the number of learners, the number of potential learners who aren't already doing the adaptive behavior decreases. So away from 0.5, there are going to be fewer and fewer people to adopt the adaptive behavior, so the change is going to be smaller and smaller as we approach what's called fixation, or everybody doing the adaptive behavior. A dot is not going to stop increasing on the way to A being 0.5. So this is the shape of selection for the success learning heuristic. Now let's turn to conformity and let's do the same kind of analysis. So what are we going to see here? Let's think it through. So conformity says that people prefer to do the behavior that is most common if the prevalence of the adaptive behavior is less than 0.5. That means that the change in prevalence is going to be negative because it's more likely that people will choose the non-adaptive, or what we call the legacy behavior. Okay, and so we have something. This time we're going to start like that. Okay. As more and more people do the adaptive behavior, it's actually going to decrease the overall change in prevalence to be even more negative, up to a point. What is that point? We're going to say that that's C. Why am I putting it in between 0 and 0.5? Because let's think about what the change in prevalence is going to be at 0.5. So at A equals 0.5, it is equally likely that someone will, like someone who wants to know what to do next, they look around the population and they see half the people doing one behavior and half doing the other. So conformity actually provides no selection. That's just neutral selection under conformity, under the conformity learning heuristic. So it's actually 0. At 0.5, there is no selection. So conformity, this is like saying that once conformist transmission gets maybe like, somehow if everyone's learning based on conformity and the prevalence hits 0.5, there's going to be no change in prevalence, and we'll never get to a majority of the population adopting an adaptive behavior. Once there is more than 50% prevalence of the adaptive behavior, then conformity starts selecting for the adaptive behavior. And that increases to a point because, but the reason it can only increase to a point, and it has to come back down, for the same reason that success bias learning had to come back down, because the prevalence is going to 1, there are no more people not doing the adaptive behavior, and the change in prevalence slows down. Connecting all these dots, we have this curve for this sketch of conformist transmission versus success bias transmission. And now the last thing we want to do here is we're going to look at how this changes over time. And so what we have is, again, the velocity with which the prevalence of the adaptive behavior is changing. Okay, so I'm going to create a magic button here. I'm going to create a button to take the derivative, and we're going to show what the derivative is of these functions, okay, and the time derivative. And what that's going to give us is the acceleration, basically, of the prevalence, how fast, how quickly the change in prevalence is happening. This tells us that basically the force towards or away from people doing the adaptive behavior. Are we going towards fixation of the adaptive behavior or away? So let's do that right now. Okay, our magic differentiator worked. We now have the force towards A equals 1. So the force towards spreading the adaptive behavior to everybody in the population. And we see the first problem with conformity versus success bias transmission. Now, as A increases, that force towards everybody adopting the adaptive behavior does decrease, but it stays positive throughout that whole range. And it's only after a little while does the conformity force towards A equal 1, towards fixation, towards full adoption of an adaptive behavior. It's only part of that initial rise towards a prevalence of 0.5, where half the population is doing that adaptive behavior. There are less and less people available, so the change in prevalence is getting less and less over time as prevalence goes to fixation. We can see that initially there is a much stronger force towards full adoption of an adaptive behavior under success bias transmission. And problem we saw before, even though there's this force, maybe a stronger force towards full adoption of the adaptive behavior at 0.5, remember that in the original plot we saw that the change, even though the force is positive, the actual change that's going to be, it's sort of paradoxical, but the change is going to be 0. The change in prevalence will be 0 because that force is balanced out by the number of people who have already adopted the behavior. So that's it. That's the lecture on why sustainability and conformity don't mix. It started out as a Monday Minute. It grew into something more. And I want to thank you so much for your time and your attention checking this out. And I hope to see you next time. Peace.